All right, you welcome back to this class. This is Clever Minds. We are still on trigonometry, but in this section, we'll be looking at basic trigonometric ratios using another definition to explain what basic trigonometric ratio is all about. Now, given this plane, a circle, which has been divided into four quadrants, right? So, from what we can see now here, we can see that there's a right angle triangle that has been inscribed in the first quadrant, isn't it? Good. Now, let's name each of the angles. Obviously, this is the y-axis and this is the what? X-axis, right? That's the positive y and x-axis. So this is the origin, O, the center. Now, so let's call this P, point P. That's the point. Point P is along the circumference of the circle, or we can say is a variable point on the circle, right? Good. Having its center at O. So we can see that since P is lying is a variable point on this plane, this is a Cartesian plane, it's a two-dimensional plane. So definitely it will have two coordinates, x and y coordinates, right? Good. So let's call the projection of OP, right, on x-axis to be what? X. That's small x. And the vertical distance between point P and the line OX, the positive x-axis, is y, right? Good. And let's say this is a unit um, line, OP, and let's say it is what? 1, right? Good. So the angle now between OX and OP is theta. That's the angle between OX and OP. That's angle theta. Now, application of the basic trigonometric ratio, remember that we have the basic trigonometry to be given as so ka twa. That is the basic concept, right? Good. Where S stands for sine, opposite over hypotenuse, that's O and H. C stands for cosine, adjacent over hypotenuse, and T stands for tangent, opposite over adjacent, right? Good. So this is just a concept. This is just a concept of solving questions using the basic trigonometric ratios. So we want to apply that here. So given this right angle triangle, or let's call this place, um, let's call this M, this point, M, right? So triangle OPM. Let's bring it out. Sorry, you can mind my lines. Right? Good. So this is 1, this is Y, and this is X, and this is theta, isn't it? So from here, and this is 19. So definitely here too is what? 19. Right? Good. So from here now we can observe that if you are going to apply SOHCAHTOA, sine theta will give us what? Opposite. Where's the opposite? That's y. That's y over 1, which is what? Y. Then cos theta will give us what? X over what? 1, which is what? X. Y tan theta will give us what? Opposite over adjacent, which is this. Can you see that? Opposite is y, adjacent is what? X. Good. So now we have just established the concept of using basic trigonometric ratios to obtain um, trigonometric values. So again, if we do um, sine sine what? Sine theta over cos theta, we obtain what? Y over x, which gives us what? Tan theta. So this an identity. It's important to note that this is a trigonometric identity. Sine theta over cos theta will give us what? Tan theta. Right? Good. So this is another way of explaining the basic trigonometric ratios using SOHCAHTOA. And when a triangle is inscribed in a circular what? Plane. Right? Good. So we have come to the end of this class. Once again, thank you for your time. This is brought to you by Clever Minds. Do have a wonderful day.